The question of how to maintain muscle strength, mobility, and independence as we age has become central in modern longevity research, and NAD precursors such as nicotinamide riboside, NR, and nicotinamide mononucleotide, NMN, are attracting significant interest in this field. Age-related muscle loss, known as sarcopenia, is one of the most challenging aspects of aging, affecting balance, mobility, energy production, and quality of life. What makes NAD precursors so promising is their ability to support the cellular energy systems that keep muscles strong, resilient, and capable of repair. As NAD levels naturally decline with age, mitochondria lose efficiency, muscle cells generate less energy, and recovery becomes slower. Research now suggests that restoring NAD may help counteract these declines, offering new hope for reducing frailty and sustaining strength later into life. One of the most compelling scientific findings is the effect of NAD precursors on muscle mitochondrial function. Mitochondria are responsible for producing ADP, the energy that powers muscle contraction and repair. Human clinical studies have demonstrated that NR supplementation can increase NAD levels and improve mitochondrial function in older adults, leading to measurable improvements in muscle metabolism. Participants often reported enhanced endurance, reduced fatigue during physical activity, and improved exercise capacity, outcomes that may translate directly into better daily mobility and reduced risk of falls. Another encouraging area of research focuses on muscle stem cells, which are vital for repairing damage and rebuilding muscle tissue after stress or injury. With aging, these cells lose function, contributing to weakness and slower recovery. Increasing NAD levels appears to rejuvenate these repair systems by activating sirtuins, proteins that regulate cellular regeneration and stress resistance. Early evidence suggests that restoring NAD may help preserve or even revive the ability of muscle cells to regenerate, potentially slowing the progression of sarcopenia and helping older adults maintain functional strength for longer. NAD precursors also play an important role in reducing inflammation, which is a major contributor to age-related muscle decline. Chronic low-grade inflammation interferes with muscle protein synthesis and accelerates tissue breakdown. NR and NMN supplementation have been associated with reductions in inflammatory markers and oxidative stress, creating a healthier internal environment that supports muscle stability and recovery. These benefits align with improvements in metabolic flexibility, an important marker of health that influences how efficiently the body switches between burning carbohydrates and fats for energy. One of the most promising findings is the effect of NAD restoration on physical performance in older adults. In controlled trials, older participants supplementing with NR demonstrated improved muscle strength and endurance compared to placebo, while NMN trials showed enhanced walking distance, better aerobic capacity, and improved insulin sensitivity, factors strongly linked to reduced frailty and better physical autonomy. Even modest improvements have meaningful real-world impact, such as easier stair climbing, better balance, and more confidence in daily movement. The broader implication is that NAD precursors could become key components of strategies to maintain independence and quality of life in aging populations. While they are not replacements for resistance training, protein intake, or healthy lifestyle patterns, they appear to amplify the benefits of exercise and support cellular repair systems necessary for building and preserving muscle. In fact, combining NAD support with regular physical activity may produce synergistic effects, helping older adults respond more effectively to training and maintain strength over time. Safety results in clinical studies have been generally positive, with NR and NMN well tolerated in typical supplemental doses, although long-term data will continue to refine best practices. Natural dietary sources of niacin, such as poultry, salmon, tuna, mushrooms, peanuts, avocado, and whole grains, provide everyday support and complement supplementation strategies. What makes this area of research so hopeful is the shift in mindset it inspires. Muscle decline has long been viewed as an unavoidable part of aging, but NAD science suggests it may be far more flexible. By restoring the energy and repair mechanisms inside muscle cells, it may be possible to maintain strength, mobility, and vitality much longer than previously expected. Instead of resigning to frailty, older adults may soon have practical tools to preserve physical power and independence, supporting a future in which aging means staying active, capable, and strong.